We're going to talk about Netflow today. How many of you guys use Netflow in your organizations right now? Okay, raise them high. Let's get a good solid count here. So 2. Okay, what are the rest of you guys using to monitor your network? Okay, ping. Okay. Well, so how many of you guys have heard of Netflow? Do you even know what that is? Okay, so at least I don't have to explain it, but Wikipedia is going to explain it for us here. So Netflow is a router feature that exports IP traffic data that can be later analyzed in various ways. So have you ever used Netflow before? You guys had some experience and familiarity with it? Okay, well, let me go first into how Netflow works. Okay, so what happens is you've got this cool little thing called a router, or a router if you're English. And so it sits out there, and it's in front of all your network traffic, in front of your firewalls in some cases, or behind your firewalls, and traffic comes in, comes out, etc. What happens is that router can generate flow information, is what it's called, and I'll get into some more detail here in a second. But every time a packet comes through, it creates a flow record, and that flow record could then be sent off to a server and then stored in either a database or flat file structures and other things. And it contains some of this information here. So you're seeing some IPv6 stuff here. Okay, this will give us a little bit more in-depth knowledge in what a flow is. So as a computer is talking to a server on the internet and traffic goes through a router, the traffic going one direction creates a flow record, and then the traffic going the other direction creates a flow record. And inside of this contains some really cool stuff. Okay, so what you can do with this data is you can do things like network protocol analysis. And so you can actually break out, here's all of the cool things that this computer or this IP address is doing. So here's who he's communicating to. Okay, so you can see who he's talking to. You can see who's attacking you. Those are really cool bombs. I found those on the internet. And so Netflow is pretty much just like a security camera for all of your little data. That's a cool graphic too, right? See, that took me probably 30 minutes to build that animation. But it was worth it. Okay, so it's like having a security camera for your data. And so here's the purposes of Netflow when it comes to security. Some people use Netflow just to kind of see how much traffic's coming in and out of my network, and sometimes people use it for billing. So if you're billing people, like, okay, you can have the first 10 gig of data for $3.99 and the next 10 for $5.99, etc. People use Netflow for that. Specifically in security, we use it for application discovery. So whenever there's a new product that comes out, especially cloud-based services, and traffic patterns start to change a little bit, we can see those types of things with Netflow. Identifying compromised hosts. This is the bread and butter of what you can use Netflow for security. How many of you guys have a hard time tracking down compromised hosts on your networks? Okay, I hope nobody has any problems, but it does happen all the time. Okay, so that goes into the same point with anomalous network behavior. So Netflow can be used to profile specific types of traffic and detect changes in those patterns. And then nefarious activities. How many of you guys have problems tracking all of the dumb little things that the people on your network are doing? Right? You had a question. Go ahead.
So I was talking with SourceFire a while ago, and they talked about all this different stuff. Do you know anything about them?
I'm very familiar with SourceFire.
And their tools to grab that, do they use the Netflow?
So they do use Netflow for some of their systems. But it's actually kind of interesting to see how many people aren't using Netflow. Okay, we actually did the little sample here. 2 out of all of you guys in this room are actually using Netflow. You're missing a huge opportunity to get a lot of cool data and look at what's going on your network. And I'm going to show you a lot of detail here. So here's a sample record of something that comes in flow data. So if you can imagine, for every single packet, or flow technically, that goes across the network, if you could start grabbing this information, how useful do you think that could be if you gained a whole lot of it? Okay, so a couple of things I highlighted. I made really pretty colors in there. So source and destination IP address, source and destination ports, the TCP flags that were set during the flow, the number of packets and bytes that were sent, source and destination ASs. If you guys are doing actual routing, BGP style routing out to the internet, this stuff is really cool, so you can see where it's coming. You can actually see the route on the routing table that was used to determine which direction that was going to go. The BGP next hops, I've anonymized a lot of this data in here. It was a real flow record, then I changed everything because I didn't want you to see it, because this is data off of our network. A couple of things to point out. What isn't in Netflow? One thing that you don't get is you don't get to see, it's not a packet capture. You don't see what data was sent. All you get to see is the traffic pattern. Okay, you saw that this guy would talk to this guy with all of that data, which makes it good because you can do a lot of high-level things without invading privacy necessarily. And so that's why we've chosen to use Netflow for our primary security monitoring tool, because we work with higher education, public education, and a lot of other people that think privacy is kind of cool. Plus, we just had a cool privacy talk that, you know, it's okay to see some of this data, but I don't necessarily say that it's the coolest thing to see all of the data. So what you can do is you can think of Netflow like a phone bill. You can get a phone bill and you can see how long you talked, who you talked to, those kinds of things, but it doesn't necessarily tell you what you talked about. Okay? Now, what can you do with all of this phone type of metadata? There is this really cool agency out there that's collecting all of this now. So the metadata seems to be good enough for them. So if you start having that metadata for yourself, you know, there's some really cool things about that. What? You laughing at me? Yeah. Mike, whatever, dude. Y'all hecklers in the back. Okay, so Netflow. I'm going to take you through just a little bit how to look, or what Netflow is about. So Netflow was originally introduced by Cisco, and they integrated into their routers, and they released Netflow version 1, which was basic. Here's the IP address source and destination, source port and destination port, and that was about it. It didn't even have timestamps and other things in there. They went through a couple of other revs of it, and they finally released version 5, which is the most commonly deployed version of Netflow right now. The problem with that is it doesn't support IPv6, so time passes, the years roll by, and now we're up to Flow v9 that's out there now, which is where a lot of people are starting to move because it supports IPv6, some other things like that. And the cool thing is Flow version 10 is now standardized open source version that's being developed. And so some of the routers don't support it at this point, but just like with, how many of you guys remember EIGRP, the wonderful Cisco routing protocol that was very proprietary before we went to something a little bit more open like OSPF and something like that? That's what we're trying to do here with v10, is we're trying to get Cisco and all of the other vendors out there to adopt an open standard for Netflow that can be used everywhere. Okay, so a couple of the devices that support Netflow today, this is not a comprehensive list, but these are the big players these days. Cisco, Juniper, Nortel, Palo Alto. How many of you guys have a Palo Alto firewall? Raise your hand. That's prideful, right?
Probably.
He put his hand back down. He's like, oh man, I'm the only one. Actually, I've really grown to like Palo Alto stuff. I shouldn't plug other vendors at a vendor-funded conference, but they do a good job. And somebody's dinging my phone. Excuse me. Oh, it's Matt. Okay. Anyways, so some of the major providers here. Let's talk just really quickly about how you set up Netflow. I'm not going to go through and demonstrate this. If you want an in-depth training on Netflow, I'll plug SaintCon right now. We're going to spend hours on Netflow and how to use it and how to develop signatures and things. But I'm going to show you a lot of that today. If you want training on it, you can come to our cool conference. What you can do is you can go into a Cisco router and you can configure it. Go into the interface configuration. All you have to do is type in IP flow ingress on the interface, and you exit out of the interface config, and you add these two lines into the general configuration. IP flow-export version 9 is what I would recommend. Version 5 is the other one that it's either one or the other at this point. But if you're doing anything that's IPv6, I'd say version 9. And then all you have to do is you set up a flow destination. So IP flow-export destination, give it an IP address and a port number, and that router will immediately start sending flow information to that server on that port. So it's cool, right? Okay, go ahead.
You don't configure verbosity or anything, it just sends it all?
It just sends it all. Well, so there are some other configuration items in there. So a couple that I didn't want to put in here is you can configure a sample rate. So you can say, hey, I only want to see like 1 in 10 flows or 1 in 1,000, okay? For us on the UEN network, which is where I work primarily, we configure 1 in 1,000 right now because doing something one-to-one flows is so heavy, I mean, with as much traffic as we have, that our routers can hardly keep up with it. We'll actually, the ASICs that generate the NetFlow will reboot from time to time because we're sending too much data, even at 1 in 1,000. So yeah, there's a number of other configuration items in here, but this would get you started, especially on just the general, don't mind my little snitch thing going on here. Where's my mouse? Hello, mouse. That's another really cool privacy tool, by the way, that you didn't mention.
Because it's not open source.
Okay, that's true.
But yes, it is super cool.
But yes, it'll tell you whenever your computer is doing anything that you didn't tell it to, which is kind of cool. So a couple of the other things you can do. So once you configure NetFlow, whether you configure that destination IP address and port number, if you just do ipflow-version 9 or whatever, the router itself will start generating these types of reports on demand. Okay, and so up at the top there's a show IP flow or IP cache flow. If you do that, your router, and I split it up into 2 pages so that you can kind of see, your router will spit out a report like this. There's some really cool and useful information here. So as you go through and you're starting to find, hey, what's going on my network? There's an anomaly. Everything's slow. There's something going on. You can come into here. This first section right here shows the IP packet size distribution across your network. And so out of all of the traffic that we pulled in at this point, you can see the point values. These can be rounded over to decimal points. So 30% of the traffic in this capture right here was 64-byte packets. And then you've got your 1,500-byte stuff generally, which is kind of interesting. But there's 96-byte packets. There's a bunch. 192 byte packets. Okay, so you can see packet distribution based off of different sizes of packets, and then it'll actually go through and it'll show you all of the types of traffic and the number of flows per second, packets per second, and all this information based off of the specific protocol that it recognizes. Now, it does this solely based on port numbers for the most part. Okay, so when it sees port 25 traffic, whether or not it's mail traffic, it's going to throw it into SMTP. Port 80 traffic is always going to be thrown into www. So there are some things that it works, that if they're doing something else on port 80, it's going to show up in here that way. But you can see that there's a lot of ICMP traffic. There's a lot of BGP traffic going on here. This is one of our core routers, so this isn't abnormal for us to see something like this. And then what it can do is it'll come over here and it'll show you, here is all of the traffic that's coming in or out of this router. So it shows me which interface that it was on, the source IP address and the destination IP address. I didn't sanitize any of this, so if you see an IP address you recognize, mum's the word. TCP traffic, so which protocol? So that would be TCP, UDP, ICMP, GRE. It would put them in there. Source port, it changes 80s to wwws. I hate that about Cisco because then you're having to write 2 different patterns in your regex expression to pull those out, but I'll show you how to do it better in a minute. Destination, the number of packets, and a number of cool other things. So this is information that you can then get right off of your routers now. So you can log into them. The Juniper stuff, you can do something very similar. The Bromance routers, or Brocade, sorry, you can do the same thing with. Okay, so we're talking about NetFlow at an open source conference. I first want to promote all of these really cool commercial engines that are out there. How many of you guys have one of these tools, something similar? So SolarWinds is probably a big one. There's a lot of people that generally have SolarWinds. What other ones do you have out here? Intermapper. Okay, do you like it? It's a pretty cool tool. Okay, but how much did you pay for Intermapper, if you dare tell me? Okay, so grandfathered in at the low level. Okay, the interesting thing about tools like this is that they cost a ton of money. In fact, I'll go back here. So at UEN, we bought one of these guys right here. Okay, $128,000 for that tool. Now, it's a cool tool. It uses Netflow to detect all sorts of finite, minute anomalies. So you can set up a block of IP addresses and you can say, start profiling this group of IPs. And as soon as something happens that's out of the norm, let me know. So it does anomaly detection. Very cool stuff that these guys are doing, but they cost a ton of money. And if they don't cost a ton of money, they don't have a lot of security-based focus, in my opinion. And so there are some open source options out there. Okay, how many of you guys have heard of Flow Tools? Okay, how many of you guys are using Flow Tools? Okay, it's kind of this interesting dying project. How about NFDump? Okay, NFDump is very cool. So I switched over to NFDump a number of years ago and started using that, and that's what we're using at UEN. You can find NFDump at nfdump.sourceforge.net. Peter Haig, a good friend of mine. I've known him for years now via email. I've never met him face to face. He lives in Sweden. But very cool guy. A lot of the development that's gone into NFDump over the last couple of years, I've kind of beat him up against the head with a mallet saying, this feature's got to be in there because it helps with security. And so reluctantly, he's been putting a lot of that stuff in there. Let's show you what NFDump can do. Okay, so when you set up that exporter and you start exporting data out to your server and you're capturing it, NFDump has a little capture engine that sits there. It's really easy to turn on. You just say, listen on port 9999, and down comes this data, and it'll start writing it out to files that are flat files. It doesn't write it out to a database or anything, but it's amazingly fast, even though they're flat files. And I'll show you some of that here in a minute. What you can then do is you can put in some really cool, powerful search filter expressions in there and pull out some cool data. So based off of that filter expression that's highlighted in orange or yellow or whatever color that is, can somebody tell me what we're looking for and then what we're looking at when we're starting to see flow data here? This is a quiz. You didn't know you were coming here for a quiz.
Just SYN scans and SSH.
Okay, so we're looking for anything that is port 22, SSH, where the SYN flag is set and that the ACK push and reset flags are not set. So what this generally will pull out for me every single time is what? Someone doing port 22 scanning, okay? It happens 24 hours a day, 7 days a week, 365 and a quarter days per year. There is somebody SSH scanning your network. I guarantee it, okay? I could put up that little meme, the Men's Warehouse guy. The I guarantee it, never mind. Okay, so what you're looking at here is I took a flow file using NFDump and said, hey, show me all of the people that are scanning me looking for SSH. Okay, and here they were. Now the interesting thing is these are all IP addresses on the Utah Education Network. That's kind of redundant. And here are a bunch of IP addresses from outside. And so these are all scans coming inbound. It happens all of the time. Cool thing is you can do IP correlation with NFDump. And so I'm using that same filter expression here, but I'm telling it to sort based off of source IP and then by flows. And then what it does is it shows, here's the guy that's scanning the holy hell out of me. And then the rest of these guys are slow scanning me for the most part. This guy's going crazy. So out of all of the flows that were in that filter, he makes up 79% of them. This guy makes up 12, 4, and the rest respectively. All right? And so he's scanning like crazy, this guy. Okay? Cool things, right? How many of you guys would like to be able to see something like that on your network, right? Okay. Well, this is all cool, but this is command line crap at this point because you're going in and you're typing this in and such. Let me show a couple of other things real quick. It does also summarize all of this. So out of all of the data that it saw, because you're seeing everything, filtering this, here's the number of flows that matched inside of here. Here's the total number of bytes, packets, bits per second, packets per second, or average packets per second. So average, never mind. You know what you're tech geeks. You know what those mean. and the time windows, the number of flows processed, all those things, provide some really cool statistics. Well, what if we threw a GUI interface on the front of this? And so that's what we've done with the Mantela Project. So this is a project we developed a number of years ago that's in a current rewrite. So I didn't bring any slides for Mantela v4.5 because version 4 was just a new command line backend. 4.5, we're developing a lot of cool new features that use d3.js for visualizations, plotting, graphing, things like that. So maybe in a minute I'll actually show you how you can go and you can search for an IP address and it'll build all the little blobs that it's talking to and such. But this is the Mantela version 3 interface, and it's built on top of NFDump. And what we're doing here is this is just the main dashboard. It's showing the last 5 minutes worth of data at any given time, and it's showing all of the top talkers. So here's the people that are sending the most number of bytes, packets, and flows. Our darknet stuff, I'll talk about that in a minute. And then I build a number of modules here for miscreant types of activity. Now this wasn't taken at the same time as those flows, so this report right here is essentially what I ran just a minute ago, or what you saw a minute ago, of all of the top scanners. You might recognize that it was done somewhat in the same time frame because I saw a lot of those. If I come back here, the 193, 29 stuff, these guys are slow scanning us like crazy. But you can see some of those pop up in here. So cool, interesting. Well, what you can do then is you can drill in even more. You can click on an IP address and then start seeing all of the traffic. Well, actually, you didn't click on an IP address. You can use those same filter expressions up here at the top. And so I just said port 22 and flags equals SYN. Now, since this one right here had an ACK push in it as well, it still met the requirement of the filter, so it displayed it. But this one actually might be a legitimate conversation going on in here, so we'd have to adjust the filter expression just a little bit. But you can see all of that data. Here we go. I think I fixed it with this one. So TCP flag SYN with no ACK pushes on there. This shows just all of the scanning that's going on. Kind of cool. Yeah. You guys are all just glazed over. It's not even after lunch yet. Okay. Let's do this. I'm going to show you, I'm going to do what I normally don't do and give you a live demo.
Demo gods are going to curse you for this. They always do.
No, believe in it. Believe in it.
Demo gods are going to curse me, for sure. Okay, so this right here, I'll make it bigger. I should have not resized my window to make it bigger. Sorry, this is just all the craziness that happens in demos. Can everybody see that pretty well? Let me show you the structure that we've got, or explain it. So what we have is we have two servers that sit back and listen for all of our flow data that we've got. And they take it and we do internal and external flows. Internal flows are all of the ones that connect to all of our internal customers at UEN. So those are all the institutions of higher ed, high schools, elementary schools, middle schools, charter schools, all those people. Okay? And then we do external flows as well, which is all of our border. So we see everything that's coming into the network. This way we can see both sides of any given conversation for the most part. And then that data is stored to an ultra-fast RAID array that's provided by our Unix administration group. They do an incredible job. And it's super fast, so I can do things like this. And then, see how fast that is? I'm just teasing. That looks terrible. Only because my SSH session's jamming up. So here's just raw NetFlow coming off of our server up there. And I'll kill the connection. It'll take a second because it's trying to jam a ton of data down that SSH pipe. So again, excuse me if there's any IPs in here that you recognize, because I don't normally just show raw UEN data here, but technically we're a public organization. This is all public record anyway. So Here, it is. If you want to come do a grammar request for my flow data, you're welcome to do it. So here is just raw flow data. The cool thing about something like this is you can start pulling out very specific data. So I can write an expression that says port 25, and well, let's just do that for a minute. Let's start this. Okay, here's all of the SMTP traffic, or stuff that's going over port 25 that's happening on our network. Now, to narrow down and find our spammers and compromised machines that are sending out a bunch of spam, we can do a lot of other cool things. So I've written a couple of signatures. I'll show those to you in a minute. Let me show another one. Here's our port 22 traffic, and I'll immediately hit the Control-C button on that one. Because there's a ton of it. So you can kind of see here, look, I didn't even look for specific types of scanners in here, but we've got this 114.80 that's systematically going through. If you look at it, he's systematically going through and scanning every single IP address on that 137.190 network. And so it's really easy to start pulling out those types of scans and information. Then there's going to be some legitimate scans. Let's provide long format here too, so I can bring in the TCP flags, some other things. Man, this is just not behaving very well. Come on. But you can come in, you can start seeing conversations as they've gone through the full SYN, ACK push, FIN. So here's a complete SSH conversation that went through the process. So you can start breaking out the normal ones here versus the ones that are the abnormal ones, the ones that just do a SYN scan. You see the ACKs going back and things. The other thing is we can see who's responding to SSH scans and all sorts of other things. You can write complex filters. So let's do, for example, host 8.8.8.8 and not port 53. What do you think we're going to find there? Everybody knows what 8.8.8.8 is? Okay, it's a Google DNS server. I just said ignore anything that's DNS about it, and look what all interesting things are coming up here. Now, what you'll notice here is that I've got the IP address, a colon, and then I've got what is normally a port number here, but it's broken out in 3.3 or 8.0 and such. Those are ICMP types or protocol types. So if you looked up ICMP type 3, it's probably going to be an echo request or an echo reply, one of them. I don't remember off the top of my head anymore. And so a lot of ICMP traffic. In fact, it categorizes it there. So people like to ping and make sure that Google is actually there. Are you there? And such. Yes. Okay, go ahead and give it to me. I'd be happy to do it. 70 dot.
196.196.43.
So he is doing port 443 scanning, or no, yeah. He's doing port 443 connections. Is he heart bleeding? Okay, well, good. So this is an IP address within Mike's control, evidently. And he's beating up on the University of Utah, specifically. I know those.
It's only 90 packets. Come on, man. Don't they beat up?
It's 90 packets. Tell us what you're doing on it.
So we're doing an nmap scan on port 443.
Okay.
See how accurate you were.
An nmap.
Nmap.
Okay.
Sorry, I can't talk.
Nmap scan on port 443, and it appears in my Netflow. Yes.
And you didn't pay me to do that.
And I didn't pay you to do that, which is kind of cool. So the cool thing is you get to see, and that's also with the fact that I'm doing 1 in 1,000 flows. So it kind of shows you, even though you do a high sample rate, you'll generally get things. Because the way that Cisco does their sampled rate is that flows that they see over and over and over again are the first ones to get the boot. And so unique flows, they'll try and keep those in the 1 in 1,000 kind of thing. Helps out a little bit. So yeah, we'll pick up things like that. Any other specific types of traffic you guys would like to see here before I go over to a GUI interface? Because this is sometimes painful. Come on. Anything. Okay, so let's show you a GUI interface.
31.192.116.24.
All right, we'll humor you. What is it again? 31 dot.
31.192.116.24.
And is it doing something on my network right now?
People are going to that.
Okay, so that's interesting. That's a bunch of Utah State IPs. 129, 123 is the Utah State University. Going to port 80 on 31.192.116.24. Tell us what it is.
Do I have to?
No, I think I know what it is.
You born.
Well, it's a good thing I didn't know what. Then I don't know what. I didn't know what it was then. This wasn't the little project you were talking to me in the hallway earlier.
I guess so. It could be a lot of others because they're protected by Cloudflare. So you may have some plausible
Yeah. In fact, if I had the filters on this system for Netflix, I could show you. Here's all the Netflix. Here's the cool thing about it. Before I move on, you can profile. You can create a filter in here as long as you want within the confines of what Linux can handle. Net 205.124.254.0/24 and port 53. You can net this and net that, so you can put it together a filter that says, show me just Netflix traffic, show me just Facebook traffic, show me just whatever else that you want to look at. And you can break that out. You can see which IP addresses are talking to them, how much data is being transferred. It allows you to get it really granular about some of those things. Okay, GUI time. So this is Mantela. This is live data again. So don't tell anybody that I showed you. So this is data that we collect at the Utah Education Network and that we use to show high-level utilization on our network. This is 5-minute data, just to show you how fast our cool network is. This guy right here at the very top, he's moved 8.67 gigabytes worth of data in the last 5 minutes.
Is that like a workstation?
That's probably going to be a workstation, but here's the cool thing. Watch this. Watch this. You can click on it. And you can come in and you can see more data. So when you click on it, it runs that report again, it goes and pulls that data live. So this is the live data for this host. And let's just kind of see. Can anybody figure out what he's doing? It's HTTPS traffic for the most part.
Is it a repository?
Could be big amounts of data, but in some of these flows, he's moving traffic at 13 megabits or megabytes. The interesting thing about the way this breaks it out is it's in bytes, it's not bits. I always say bits, but that's 13.3 megabytes per second. It's kind of the quirky thing about Netflow is that it doesn't do bit rates, it does byte rates. And so I could write an equation there to mathematically change it, but I just said to hell with it.
Well, why does it do it in bytes?
Because that's the way that the flows are counted, because they get aggregated at the router level. So by the time they're sent down here or sent to your server, they're already in bytes. You can't do much about it except it's a Netflow thing. And I didn't want to build another. The regex to go through and build this stuff, as it were, was crazy and such. But anyways, you can look at it and just see he's transmitting a lot of data. So 172 addresses, that's Apple stuff. In fact, I know exactly what this is, having looked at it now. And look at all of the random IP addresses, but all of these are well known. It's a caching box is what it is. So you've got Google IPs in here all over the place. You've got Apple IPs. There's some Microsoft stuff in there. This is everybody's seen the Matrix. You see the blondes and the brunettes, right? For this is blondes and brunettes for me. So because I look at this stuff day in, day out all the time, the IP addresses become blondes and brunettes. I can see it right through them. Yeah, Netflix stuff is in here too. So this is a caching server. Specifically, this is the Akamai cache cluster that UEN hosts here. So let's go back here. Let's pick out something else that might be interesting. Something I know is not a caching cluster. In fact, he's moved a ton of data.
3 gigs and 2 flows.
Yeah.
Where at?
Up one more.
This guy?
All the way over to the left.
To the left. Oh, this guy. Okay. That'll be, oh, yeah, see, that's the other problem is since I'm pulling live data off of a historical report, he's done and gone. And so I'd have to go back into manual data to see that. But the cool thing is you can break this out. This scrolls or refreshes itself every 5 minutes. And you could just sit here and watch the data that's traversing your network. You can easily make a new module to show specifically what you want. This is what I've done here. So let me talk to you just a little bit about Darknet. Darknet is this really cool thing that if you have a lot of IP addresses that you're sitting on that nobody's using, they call it Darknet. UEN just happens to have about a half a class B worth of address space left that's unallocated. So there's a significant amount of addressing. And so what I've written here is I've written a couple of modules that look for any traffic that's coming to IP addresses that I know aren't allocated to anything. And what you'll often find here is the miscreants and all those people that are out there scanning and doing their thing start hitting these addresses because they're just on autopilot, right? And so very interestingly, you can come over here and you can see the top 5 ports that are being scanned right now on Darknet are 6005. Who knows why? 2048 here, this is a misnomer. This is ICMP traffic. It's a bug. Port 22 and port 1900. Does anybody know the significance of 6005 or 1900? What are those commonly used for? I'm asking because I don't know. Generally what I'll do is I'll come in here and I'll see something like this. It might be a VNC thing, but I'll see some new traffic pattern come in, and that's when it kicks off like, hey, go figure out what this is, because obviously the miscreants are out there scanning for it for some reason. And what it most often is, especially in these more obscure ports like this and this here, are things like a botnet control port that somebody knows is out there and that they can take over the control of the botnet, things like that. So backdoors that they know are generally open on specific ports. Here are the top hosts that are doing all of these scans in general. And so 190, it's that security mechanism to make sure that when I walk too far away from my laptop, it shuts down. So top port, or excuse me, IPs or hosts, and then protocols. The protocols don't normally change except in order. So 6, everybody know what 6 is? I should just write another regex expression to switch that out. That's TCP, UDP, and then ICMP. And so those are the protocols. So when a lot of UDP types of scans start coming in, you'll see that change and flip around. Okay, let me show a couple of other ones that are live here. I'll refresh the page just to make sure that we've got live data. So here are all of the machines. I've written a fairly complex filter that shows source IP addresses on my network that appear to be scanning outbound. So this is really good at finding machines on our network that appear to be scanning outbound. And it's going to be one tiny little packet in here that it's going to find, I bet, that it's doing, or that it's matched on, because most of that looks like legitimate traffic to me. So moderate false positive rate on version 3. Version 4, we've written some better filters in there. Let's show you a couple more here. So here's the brute force SSH scans that are going on the network. Like I said, live data versus reported data. Damn it. So here just shows you, similar to what we saw before, but specifically this 91.212 address is slow scanning through the 205.122.233 network. And you can see it somewhat in order. The other interesting thing about Netflow is that it doesn't always send it to you in the order that it came into the router. It's kind of a weird thing. And so he's probably very specifically going from 1 to 2 to 3 to 4, but you'll see that they're flipped around. And I don't correct for that in this version of the GUI here. But because it takes a whole nother processing step of the flow data and adds time to it. Go ahead.
With the timestamp there, it's all in consecutive order,
that specific time is the last time it saw the packet. So a flow is measured from the first point that it sees it. The router will start a flow record and keep it there, and it'll wait for more information. And then that timestamp ends up being the last timestamp. The other interesting thing is in Flow version 9, here's a cool difference, is it shows now the first timestamp and the last one. And so in version 4, we switched it so it shows the start timestamp, not the end timestamp, which made it a little bit better. So that's why I said I didn't fix the ordering in this one. Let's show you a couple of other things, and then we'll get you off to lunch a little early. So we showed you this, SQL scanners. This one's probably a false positive because he's on my network. Those of you that we wrote a couple modules back in the day when TorPig and DNS Changer were a big deal, and I've just kind of left them in here. And so there's good. The good thing is we're not seeing any DNS Changer infected hosts or TorPig MeBrute infected hosts on our network right now. It's kind of the passe thing, but we do have PushDo, Citadel, and some of these other signatures that are now in our version 4 stuff, which I'm not showing you yet. You can come to SaintCon and see that. How's that? Okay, let's show you advanced search capabilities. All those filter expressions that we showed you before are available in here. So you can do port 53 and not host. Come on, and not host 8.8.8.8. And you can really quickly and easily, depending on what type of data you're looking for, focus in on what you want to see. Let me go back here. You can do nested searches here as well, or you can nest it. Everybody's familiar with TCP dump, filter expressions. This supports almost all of those, and that's how it's been written, is using that library. So there's a few things that TCP dump can do that Netflow can't because you're not getting that deep into the packet. But anyways, I'll save it. Any questions, comments, suggestions? Anybody want to help develop it?
When does 4 come out?
Okay, so 4, the command line version of 4 is out. You can go to the utahsaint.org/projects page, and you can play with 4, but it's just command line right now. 4 is being actively developed. I haven't even put the GitHub stuff up there yet because we just started it less than a month ago. So we're going to wait for about another couple of weeks, and then we're going to push what we've got and let people start playing with it and developing on it. Because we want everybody's contributions in the way of developing signatures for it. If you work with d3.js, raise your hand. We'll take your expertise and incorporate it because I suck at d3.js, but I'm doing my best. Right now, there's 2 people actively developing it, and we're looking for more. So if you guys have time, want to help build a really cool tool, we're looking for more help. So any other questions? Go ahead.
What's the difference between Netflow and SFlow?
They're the same thing. One's just, who does SFlow? It's Foundry does SFlow. So it's the same exact technology. NFDump will take SFlow information as well as Netflow information. The other cool thing is a lot of the new firewalls, Palo Alto's firewalls and such, send a version of flow that NFDump understands now too. The difference is that when you're processing that data, SFlow sometimes, depending on the router type, won't send TCP flag information. So that'll always just be empty for you. So there's some nuances, but it's all the same thing. Go ahead.
What about the differences in JFlow?
They're the exact same. So JFlow is Juniper's version of Netflow, and they're adhering mostly to standards, which is good, so that when NFDump gets it or whatever collector you're using, it can understand it and it's not foreign. Anybody else? Questions, comments? Okay. Well, then the last plug will be we're going to do a full training on Netflow at SaintCon. So we're going to go through and we're going to show you how to build your own filter expressions. We're going to be using Netflow v4 or Mantela v4 up there. Everybody can take it home and such. Look for it on Utah Saints website. We'll be posting it as soon as we get a GitHub version up there. We don't want to put blank. The thing I hate the worst is when you see a project out there and it has nothing in it. So we're going to wait until we have just a little bit, enough to get you started, posted in it, and we're expecting it about a week or so. All right? Okay, you're about 10 minutes early for lunch, so enjoy. Thank you.